Okay, first of all, we finished the visit pattern already on Monday. So if you go to the lectures page, I mentioned about this tutorial video. So if you click on the composite visitor design patterns, so there is a tutorial project over here to walk you through the basics about the two patterns. You will need them for lab number 5. Okay, so it might be nice for you to maybe have a look and try it out on the iPhone Studio before you receive lab number 5. It'll be a very good exercise. Okay, so if you got any more questions about visitor pattern, let me know. Let's start a new pattern, okay, today. It's the state design pattern. Okay, the name is not really important. I think it's more important for every pattern to notice what kind of problem we are trying to solve. So the problem we are trying to solve for visitor and composite pattern is you want to build some kind of like a hierarchical system in which you have basic versus recursive components, and they want to have a way to traverse the tree structure by various different operations. That's the composite visitor we talk about. Now for the state design pattern, it's going to be a different flavor of problem. We're going to have a look. Okay, let's have some motivating example over here. So now, let's consider some online reservation system for tickets, for example, right? I included a website. Hopefully the website is still active. Let's try. It's a real website. Oh yeah, if you go to this website over here, it's basically for you to actually book the flights from somewhere to somewhere. Basically, you enter some information here. You go to the next page. Maybe they'll ask for if you're a VIP member for the website, and then ask for your credit card information, and then your mileage, maybe Air Canada mileage number, things like that. So basically, that's kind of the problem we want to solve. Not necessarily a web application, it can be a mobile application as well, maybe even more common these days. You basically have some starting page or starting states, and then you may be prompted for different inputs. Depending on the inputs you choose, for example, you might say, I'm VIP member, or I'm not VIP member for this website. They might branch out to different states or different pages for you, depending on what you choose. So it's really state dependence, kind of like an application over here, okay? So that's just one application over here. Okay, so now for simplification, for demonstration in the lecture, let's consider something like this. Okay, very similar. Let's say we have some online reservation system for air tickets. So maybe you can want to say, I want to fly from Toronto to Zurich in Switzerland. And then the departure dates on or before, very regular information. And then for the page, let's say it's very conservative, conventional. You simply just say you can either enter 0 if you want to exit from this page. I don't want to continue anymore. Or you can say number 1 for help, and number 2 you want to have some further inquiry, or you have number 3 to actually reserve the seat. Okay, things like that. So basically, for every page, while you're interacting with the website, for every page you do have a list of options, and the list of options that's available depends on which state you are, right? Okay. How many of you took 2001? How many of you have not taken it? How about that? That'll be easier. Okay, that's good. That's the advantage of teaching a CS session. I think for the other session, most of them didn't take it. You learn about DFA, right? Oh yeah? What does DFA stand for? Depth first search? That's DFS, right? Not DFA, right? Deterministic finite automata. Okay, good. Wow, that's good. I like that answer. You were teasing me, right? Okay. Good. That's okay. All right. We're gonna use that. Okay. However, to make it a little bit more general, you also learned back in 2001. For modeling purpose, sometimes it might be easier to use an alternative to DFA, which is called NFA, non-deterministic. So we'll see that, non-deterministic, okay? But you do have a procedure to turn NFA into DFA, right? Subset construction, well, if that makes sense. If no, that's okay. It's not required for this course, okay? As long as you can understand a simple state diagram, you're okay for this course. So now let's see this state transition diagram, okay? That's why I mentioned about 2001. Since most of you took it, so it's easier to start from there. Basically, what we're dealing with is kind of like an interactive system, which means the system might stay active for a very long time. And then depending on the user input and output, for you as a user, you have to actually give some users state-specific information, and the system has to react accordingly. Okay, that's kind of interactive system we're talking about. So now, how do we characterize it? We can say a set of states or like a set of pages, on a mobile phone or on your website. And also, for each state, the list of applicable transitions, right? We talk about transitions. Of course, when you implement a transition, it can be a hyperlink, or it can just be input from the user, 0, 1, 2, 3, 4, right? The input, okay, actions. So now, the above reservation system that we just talked about over here, for simplicity, we're going to assume for this system here, we have the following state transition diagram. I'm going to go over them together with you, because we're going to need it. Okay, so now let me just go to iPad over here very quickly. Oh, question for you. What will be the data structure to code the transition? Well, of course, this absolutely you can just use a graph data structure, right? You can say you got so many vertices, also you got a transition between. How do we implement a graph? Back in 2011, how many ways can you implement a graph? Huh? Adjacency matrix. Yeah, that could be a matrix, right? Or can use adjacency list or edge list. You got 3 different possible. Let's say adjacency matrix. So you're going to use a 2-dimensional array. Agree? So that's something we'll talk about just for this particular pattern here. Okay, so for example, conceptually, you can think about what we're doing here is something like this. For this diagram, let me just show you very quickly conceptually over here. Let's say we got 6 different states. Let's just help you understand this. We're going to use the same diagram throughout the lecture. So we have basically 6 different states, 1, 2, 3, 4, 5, 6, right? 6 different states. And then each state is going to correspond to a row in your transition table. Basically, the row will be the states. So that's why I got 6 rows. And the columns is going to correspond to how many options the user might choose. Okay, it can be 1 or 2 or 3. But not necessarily every state is going to support each option. For example, let's say if I'm now in the states over here, I'll give you one example. If I'm currently in this state here, let's say seed inquiry, which means I'm here. If I'm in this particular state, there are only 2 options for me. You can either follow transition 2, and then I will go back to flight inquiry. Or I can go for reservation by using option 3. So there's no option 1. Option 1 basically is only for if you want to finish or ask for some help. Okay, that's how we read the table. Okay, as you can see, this is not a DFA, it's an NFA. Because the set of transition is 1, 2, and 3. But not necessarily every state has all the transitions supported, right? That's why I say it's an NFA, non-deterministic. Okay. We're gonna go over more about this diagram here. But is anyone not comfortable with thinking that these 2 things are really equivalent? So now, if we want you to, not in the lab test, but maybe in the exam, if we want you to implement this transition diagram, let's say we give you the transition diagram, are you able to create the transition table accordingly? Okay, that's my question for you. If you think you're able to, good for you. Okay, we're going to revisit this diagram in just a moment. Okay, for now, let's just go on. We're going to, okay, so design challenges. So now we're going to talk about basically something you learned back in 2011. Okay, let me bring you to the connect to you. Design challenges over here. So now, since we talk about state transition diagram, right? We know that realistically, a very realistic system, the number of states can be large. Accordingly, the number of transition can also be large. Back in what you learned in 2011, if I got n states, what will be the big O, the upper bound for number of transitions? N squared, yes, correct. That means every state has transition to every other state, basically, right? You got n times n minus 1. Okay, that's what we learned. So I'm just talking about the complexity, the inherent complexity for this kind of problem here. So given a large number of n, you might have a large number of states. You just cannot get away from that. Okay, and number 2, the graph structure may not stay stable, which means you may want to add states or remove states. For example, let me illustrate to you. We don't necessarily do that for our remaining illustration, but at least you should know. Later on, when you design your state pattern or to solve this problem, you always want to keep in mind Dynamically, the user may want to say, I want to get rid of this page. Maybe it's not really, it's kind of obsolete. Or I want to add a new page for the user. Okay? For example, according to the diagram over there, you might want to merge, let's say, state 2 and 3. In that example there, let's say, let me just clear that quickly. So now at the moment, so this is our state transition diagram. So now how do I merge, for example, let's say these two states into one? Right? So now if I want to say, I'm going to merge these two states over here into new states, right? So somehow I want to make sure this connection here can still work seamlessly, and also this connection can still work, and this can also work, and this can also work seamlessly, right? Also, there may be some changes I need to deal with internally, right? You may want to merge them into a single state. Okay? Alternatively, I may also split a single state into two different states by adding more transitions. So here we are reducing transitions. You may want to add transitions as well. Okay? You want to think about how you can grow the table dynamically. Okay? So these are some design problems you want to keep in mind. Okay? You may delete and you may add. So now, what about a general solution? So we really want a general solution that is going to be not specific to a particular problem you're solving. For example, the problem we're trying to solve right now is only for the air ticket reservation. It might be for Amazon, it might be for eBay, or it might be for other online shopping system, right? It can be anything. You want to make sure your solution can be easily taken from one application to another by modifying just a little bit more instance-specific details. Okay? That's something we want to achieve. But as usual, we're going to see some poor solutions. They might work, but it's very ugly and not very elegant. So we want to criticize on those before we get to the final one. Okay? That's a usual roadmap. Okay, so these can be the examples. You can go to the link and see what kind of a system you might design. Okay, now let's try the first design. The first design, you can even achieve it without using any OO language. You can even achieve it using a C language, for example, or even MISP. You learn about MISP in 2021, right? When you talk about assembly language. The first design, sorry, what's the language you learned? Huh? Right, yeah, whatever, okay. Some assembly language. Basically, you know that for every assembly language, they support something called label. You can say, I declare a label over here, and later I can say, go to that particular label. We can easily use that construct here to have our first design working. Okay? Let's have a look to get an idea. So now let me go through some code very quickly with you, just as a little pseudocode. Okay? Just get an idea. Basically, for every state, you're going to have a separate label for that. Because we have 6 different states, we got 6 different labels. Under each label, you're going to define some code over there. Okay? So you got label for state number 1, initial panel, state number 2, number 3, and then this is the particular state I'd like to go into detail to show you some details. Okay? Number 3, number 4, number 5, number 6. And overall, we got 6 different regions of your code. It's a single piece of code, like a Superman class, Superman module. Everything's in a single module for our reservation system. Now let's have a quick look to see how the label number 3 might look like. And then I want you to think about, given we know how to implement, let's say for label number 3, how do we implement the rest, right? That can also give you some idea about design. Let's have a look at, for example, seed inquiry. If you just go back to the state transition diagram over here, okay. If we are currently, again, let me clear this diagram very quickly, okay. Basically, we're trying to define the implementation for state number 2, specifically. Okay, actually, let me see this. State number 3, sorry. So now, let's say I'm currently in this state. I'm trying to define what's going to happen over here. Okay, so now, eventually, the user might decide to either go to this way, or they might go for this way, right? Just keep that in mind. Okay, from state number 3, we can either go for action 2 or action 3. Okay, so now, how do we define the code quickly? So now, for this particular label, this is what I would do. The idea is we're going to display some information for the user on the web page or on the or on your mobile screen. Display some information to tell the user what you should really enter for this particular page. And then the user is going to enter something. For example, they might enter their membership number or enter their credit card number. And then the program is going to do some validation So if the validation failed, they might still stay in the same in the same states, and then we'll keep prompting them for the information until everything's validated. Once everything's validated, we'll proceed, we'll process the information they have entered, and then do something. After that, we'll ask them which state would you want to continue to, right? That's kind of the flow. Let's have a look at that very quickly. So first of all, we display the seed inquiry panel. Okay, we might say these are the seeds that are available on the plane, or for the time you specify. Okay, we're not going to. So you can see the from until. Okay, basically we basically saying that we're gonna keep running the loop until it is not the case that the answer the user enters is wrong, or the choice they enter is wrong. Okay, for example, what can be a wrong choice? The user, let's say currently they are in state number 3 over here. If they say they want to go for action number 1, this is the wrong choice, right? So this is the wrong choice. If the user simply say, I want to go for action number 1, you should really tell them that, oh, it's not possible. You cannot go for action number 1. You should go either 2 or 3, right? What about wrong answer? Wrong answer really depends on what information prompt them to enter, credit card number, address, or whatever, right? Subject to some validation process. Okay, so make sure you're comfortable with this loop structure over here, okay? So now, for every iteration, basically we're going to, first of all, you're going to prompt the user to enter something to the panel, right? To the interface. And then you're going to, basically you're going to read their choice. And then you want to say if either the answer they enter, like a credit card number, is wrong, or the choice they enter, for example, if they say, I want to go to action number 1, that's also wrong, either way. And we're going to give them some opposite error message, right? So now, if we can exit from the loop, so what does that mean? If we can exit from the loop, that means this particular condition over here is true. That means both the answer and choice are correct, okay? If we exit from the loop, we can now process the answer. For example, we may just charge them for the credit card, for the reservation, right? Some deposit. And then we can process the user's answer, and then we can say, now, the C is the choice the user say, I want to go to a particular state. Okay? We're going to say C, it can either be 2, in which case we go to. What does that mean? So this is really crucial, right? If the user say, now I'm in state number 3, I want to go to state number 2. That means I want to do the following. Okay, I'll show you this. Conceptually, you can think in this way. I'm talking about this choice specifically. Okay, this one here. From the diagram, we are currently in state number 3. And the user say, I want to choose to go to state number 2, basically, right? I will choose action 2, and then I want to go there. How is that reflected in the implementation? That simply means I will go to the label for this particular, will go to this particular label, which means I'm currently here. I'm actually just going to this particular label over here. Okay? So both conceptually and programmatically, you should know what's happening over here. It's a very simple computational model. Declare the labels for each state. Under each label, declare what's going to happen for each state, and then go to the corresponding one. You can go to multiple different ones. Any questions so far about this first design? Easy to understand, straightforward. Okay, you only got a single module, a Superman module for you to define. That's it. Any questions technically about this solution here? I just want to make sure you understand this before we try to criticize on that. Since we talk about this solution first, that means it's the worst solution, right? Okay, we're gonna improve it a little bit, and then we go to the final pattern, right? Hopefully you can see the roadmap. I think that makes sense. Okay, now, can we agree that this is bad? You don't need to agree. Let's say we agree. Now, can you criticize on that? What's bad about this design over here? Let me give you a little bit hints. Number one, let's talk about debugging. That's one thing. Because when you afterward you want to program something, program your design. Debugging is a very important thing for you to actually do at the runtime. The other one is about reusability. Reusability in the sense that we don't necessarily just want to develop our design just for this particular reservation system. Maybe 2 months from now, we got another request from our clients. They want us to build another online shopping system, which is very similar, but not exactly the same. Would it be easy for us to just take the existing solution there and then easily adapt that to that particular system, which are both interactive, right? So now what about the first one, debugging? Is it easy to debug though? Okay, the answer should be no, okay, in the following sense. I'm not sure if when you took your first year Java course, right? So, you know, in Java, so there are 2 keywords you might learn when you learn about the loops. One is called break, the other one is called continue, right? So these are the 2 keywords. These are kind of legacy construct from the C programming language, right? So there's one school of thoughts that you should not ever use continue or break in your program, even though you're sure it's going to work. In a large system, if you actually use lots of a continue and break, you can end up with something called spaghetti code. I'm not sure if you heard about this term before, spaghetti. You have seen spaghetti, right? Basically, you got lots of noodles scrambled together. It's just hard to tell which thread it is, right, in the spaghetti. We are running into a similar problem over here. Okay, I'm gonna maybe include, I believe I got a maybe paper included in the slides. I'll refer that to you, just for your information. What we're having over here is a similar concern over here. You can think about what's going to happen at the runtime. Okay, just an illustration. Let's say this. Let's say we started with basically over here, and then somehow we reach to the end, and then we might go to state number 6 just as an illustration. At the end, we go to number 4, and then we go to number 6, go to number 5, go to number 3, go to number 2, like that. So when you actually look at the log of the labels you have traversed through, it's very hard to really see what's going on over here. It just looks like a spaghetti. Okay? That's so-called spaghetti design as opposed to spaghetti code. Okay? Basically, just hard to trace. That's my point. Okay? That may not be so bad if you're comfortable with tracing at a low level. It may not be so bad. I'm just saying it's a bad practice, especially when you got maybe hundreds of states. You wouldn't want to trace like this, just by going from label to label. It's difficult. Okay? So now, I tell you what, the second thing maybe should be of more of our concern. Okay? So currently, you know what, before I talk about reusability, let's talk about another one. Okay? I forgot. Oops. So debugging, basically what I am telling you is you might end up with spaghetti code. Spaghetti code. I forgot how to spell that. And then for the second one, single choice principle. Let me give you hints. Do you think single choice principle will be obeyed in this particular design? Why? Why is that? Can you describe a scenario where it would be? Yeah, go ahead. Oh, the third one, yes, correct. How similar? Take one example. Let's say we go for number 5. Let's say.
Yeah, like the from until we just kind of copy pasted it.
I agree. Yeah. Basically, you can imagine that's exactly right. What's going to happen is if I want to, let's say I develop state number 3 already. Now I want to develop for number 5. All I need to do, copy and paste the whole fragment, and then this maybe change the contents for the display a little bit. And then the condition will be the same. And now I just need to change this a little bit to see what information should be read from the user. And also read the choice the same, just read some character maybe from the user. And then also define what do you mean by wrong answer, what do you mean by wrong choice. The pattern over there is really the same. Or to be more precise, the template of the interaction is really the same. Okay? And you're repeating the same template for 6 times because we got 6 different states. What if I got 1,000, well, let's say I got 100 states, 100 times. And what if I decide to modify the pattern a little bit to say I always display something, even display something at the end, for example. In that case, you got to modify every fragment of the label, right, 100 times. Okay, so that's violating single choice principle. Okay, so that's not good. Okay, lots of duplication. Duplicates between labels. Everything I said here is on the slides. Don't worry. I thought it would be more useful to discuss that quickly, informally. So now, what about reusability? This is even more the concern because we want to make sure whatever we design and implement can somehow be reused in a way. At least we don't have. Well, we can still do copy and paste, but hopefully it will be very minimal changes we have to make from one application to another. So now, what if I want to say, let's say this. Now I want to change from a flight reservation system into some online shopping system. Okay? What do I have to change really? Okay, I'm basically moving from one particular interactive system for flight reservation to, let's say, online shopping like Amazon. If I do if I want to develop a new system, what do I have to change over here? Okay, let me go one by one. Okay, states, I heard that. Number one, are we going to have the same states as before? No, right? Because these states, the label names are very specific to this application, too specific. So maybe you're just going to change completely the name for the labels, first of all. And also, not to mention that maybe the pattern of interaction might be different too. This pattern over here, this template, is only applicable for this particular reservation system. If you move to another shopping system, you might have a different interaction pattern. So reusability is not good. Okay, number one, the states will be completely different, and also the templates for interaction will also be different. Okay, that's not good. Yes? Well, it could be that, well, I'm just saying, because we're moving from one system to another, potentially, maybe that new system is expecting a different way to interact with this, the user. Maybe they'll always prompt the user first for some login before you display anything, right? In that case, you gotta swap around things, right? I'm just saying, when you go from one system to another, No, it's actually about the interaction over here. I'm basically talking about over here, under a particular state, let's say state number 3 over here, what kind of pattern do you expect to interact with the user? Currently, I have a very particular pattern for interacting with the user, right? But it might change. If I want to change it, I need to change in different places, right? I got to go to under every label and then go to change that pattern over there. Let me just give you one very simple example. Let's say the only change I want to make is to say in the beginning, I do not want to display anything to the user. We simply prompt them for the answer directly. And then we only display something at the end. It's a pattern change, right? Simple change. Basically, take out the beginning, move it to the end. How many times do you have to do this? So many times, right? Corresponding to how many states you have, right? That's not good, right? It would be nice to have a single place to design, to develop, to store this pattern. It would be very nice. And that would suggest maybe inheritance will help eventually. Inheritance. Okay, that's what we'll see later. Are we okay with this? We're just criticizing the design quickly, right? If you move on to the next, to the slides, basically that's exactly what we just talked about. Okay, the first one about spaghetti code, spaghetti design. And also, you can see that somehow the current design over here is too specific to the application we're trying to solve. That's not good. You want to make it general enough. And also, also violates the single choice principle. The design smells. Got so much duplicates. Okay, so finally, so this is also important. The final point is really about separation of concern. Basically, you want to have at least two concerns over here. One concern is about the state transition itself, right? If I am in a particular state, I want to transit to another state. That's about state transition. There should be only a particular aspect of the system. But somehow, this particular aspect right now is basically exactly how your code over here is defined. Because you can see currently we simply put every state into a particular region of your code over here, and then we simply say at the end, just go to, right? Basically, the way you code it is just how you do the transition table. That's not good. You really want to say only make it a feature of your system for the transition function, only a feature, okay? Anyway, this design is going to work, but very poor, especially when you talk about changing it later, okay? Any question about the first design? Are we okay? Good, okay? Now, second one. The second design basically is going to solve some problems from the first one. For number one, we're going to have separation of concern. We're going to basically make the transition a separate individual feature or aspects of our system. Basically, we're going to declare some query or attributes for the transition table. Okay? Let's see how it's going to look like quickly. And then, again, we're going to criticize on that. That's not the final solution just yet. Okay, separation of concern. So we're going to describe the transition table as a feature of the system, rather than the whole system is just like a transition table. Okay? So now, this is some feature we're going to introduce over here. Okay? It's just going to call transition. So now, to make some example for you, you can see the transition feature here. It takes two parameters, right? You can take the source states, and then the choice, and then it's going to return the target states. And you can see there's some precondition over there to say that you can see the first precondition there. Okay, let's have some quick note over here. Okay, the fragment over there, you can see the first precondition here. The source states over here should be between 1 and 6, simply because we only got 6 different states over here. Okay, that's the first precondition. And the second precondition there is to say the choice must be between 1 and 3. That's because we only got 3 columns over here in the corresponding transition table, right? Good. Let me just make one example for you. Of course, also the post condition here is to make sure whatever return value it is, it must be a valid state, right? So that should be also between 1 and 6. So these are easy contracts for you to write. Okay, we don't need math model in this case. That's fine. Okay, just make it simple. Now let's. For example, you can see that I got some example for you. How do you do this? What does this particular feature call really mean? So when I say 3, 2, what's the difference between 3, 2 and 2, 3? Okay, how about this particular one? So that means I am in state number 3. And then the user says they want to take action 2, which will give me the return value 2, right? What about 2, 3? 2, 3 means the opposite. I'm in state number 2 and take action 3, which will give me 3 instead, right? It got directly, you got a completely different outcome. Okay, be careful with that. Okay, so now you can also try to do transition 3, 3, in which case it will just be, for example, 3 here, 3 here, which is going to give you 4, right? It's different. So now, you just have to know how to implement that in the 2-dimensional array. So now in this case, for example, I can simply say, for example, I can say states, and then I can simply go to row number 3 and then column number 2, right? That's what I can do. By the way, if you want to do this in IFO, the syntax, be careful. You have to do for the 2-dimensional array. This actually wouldn't work. I know that's the syntax from C, also in Java. In IFO, if you got a 2D array, you have to say states. And then you have to say 3 here and then 2 here. Okay, just a minor issue for you to notice. But idea is really the same. At the runtime, this is how we're going to initialize later. Okay, we'll do that matrix initialization later. Okay, good. So now that's about the separation concern. So we got a transition feature which works well. It's easy to implement that too. So now we're going to implement using a 2-dimensional array, as we said. Okay, you should know how to initialize that too. So now let's now talk about this second design. It's actually going to not use object orientation. Okay, it is going to use basically hierarchical design, which means you can also do this solution here also in a non-OO language like C. That's possible. Okay. Let's see exactly how this design is going to look like, and then it's more important to understand the eventually transition from this design into the state design. You can really see what's the fundamental difference between non-OO and OO. Okay, it's a more general solution because we got a separation concern. Okay, we got a separate feature for the transition table. Okay, reusable in the sense that whenever you move to a new system, you're just going to change the transition feature. Okay. So now let's have a look at the design. This is a top-level feature, top-level diagram you have to understand. Okay, we'll go over that. Okay, together. Basically, let's move on to this diagram over here. Okay, it's top-down in the sense that whenever you want to execute your particular system to start interaction with the user, you have to start executing from the top. I'm going to show you some code a little bit later. At the top level, we got a feature called execute session. Okay, so this is the feature you have to execute first. Inside the execute session, it has different stages, right? Execute session is going to do 1, 2, 3, 4 different stages of actions. Action number 1, it is going to initialize the states, what the initial state should be. And number 2 is going to maybe try to do a little bit transition over here. Okay, we'll see the detail. And number 3 is the most important one over here. Execute states. Execute state simply means based on what the current state is after the transition, do something specific to the states. Which means if the current state after transition is confirm flight, it might do something different from if the current state is simply help, right? So it depends. So this is something, that's why it got subdivided into the third level. Okay, that's something we'll see too. And after the third stage, we're going to move on to the last stage, which is to check whether the state currently is a final state. Because as a final state, that means we're done. We're done with the interaction. If it's not final, we're going to repeat the same process again, over and over. So that's why it's interactive. So now we want to see, so now we have seen level 3, level 2. Let's see level 1 very quickly. Level 1 basically comes from the stages in execute states. Okay? How do we deal with individual states? Depending on what the current state is. Okay, let's see that. To really handle a particular state, we're going to say, for example, if the current state might be either 1 or 2 or 3 all the way to 6, right? We'll talk about state number. We're going to display differently based on what the current state is. We can say if the current state is 1, display this. If the current state is 2, display something else, right? Similarly, you're also going to read some input from the user. Again, depending on what the current state is, you're going to read differently. Also, you're going to do some validation on the user input, also depends on what the current state is. And then you're going to message accordingly, and also eventually you're going to process the information for the current states. It's a very rough picture of what's going on, but I'm going to show you more details of the code so you make a little bit more sense. It's called top-down in the sense that you started with top feature over here, which is called execute session. And then it's going to be subdivided to different stages. And for one of the stages, it's going to be subdivided to another stages over here. Okay, that's why it's called top-down. Okay. Which is a very common pattern if you program in non-OO. The matter of the truth is, if some people, even if they're programming in OO, they might still program this way. That means they're really not exploiting the OO feature very well. Okay. Okay, let's see. Let me give, before we criticize on that, let's be fair. Let me show you a little bit more information about how execute session, execute states, and also, for example, display are implemented very quickly. And then we'll criticize on this design before we move on to the actual design pattern. Okay, now let's go on to let's see this. Okay, so these are just description over here. Let's start with the execute session. Okay, start with that. You know what, let me just go through the iPad, that'll be easier. So now remember, this is the design diagram we have over here. So now we talk about this particular top level execute session. Okay, so let me show you exactly how you would do this in iPhone. Even though iPhone is an OO language, but we can still program this design. It's not a problem. Okay, we're underusing the OO feature in iPhone basically. Okay, so now we're going to basically, so that's the top level. We're going to maintain what the current state is. The way we store the current state is just using an integer. It can be from 1 to 6. So you might have a class invariant to say state should be between 1 and 6. And also, what would be the current choice for the user, right? It can also should be between 1 and 3. Now, over here, we're going to run a loop. And this loop is very similar to each label that we just talked about in the first design, right? We're just going to say, first of all, let's make sure we know what the initial state is. We'll only do this once. Okay, so this is just to assign the initial states. Okay, just assign that. And then we are going to continue, we're going to keep interacting with the user until its final is a query that returns a Boolean. So as soon as the current state becomes a final state, we're going to exit from the loop and terminate the interaction. Okay? So what this means is we're going to say as soon as we reach the final states, stop interacting. How about that? Stop interacting with the user. That means we're done. Of course, it might take a long time before us can actually go to the final states. Okay, so now if you look at the body of the loop over here, let's highlight it. You will see that first of all, we're going to execute the states. You can see execute states is actually a second level, the level 2 over here, right? We're going to see the details for execute states. But now the execute states is now going to take an input over here. Notice one thing. You can see the current state over here is going to be passed to the second level, which means you can see that for the execute session here, we declare the current states. And then when we try to call this helper feature, we actually pass around the current states. You can think about the data flow. We are basically pass around the current states to it, to second level. Okay? That's what we're doing. We're going to see a little bit more details. And then after that, so now this line over here should not be too strange to you. If you look at over here, we say current states. We're going to, after we handle the current states, we're going to actually do some transition over here. So basically, we're saying that we're going to call the transition feature that we just defined, right? That's a transition query. And then there's a current states, and then there's a choice by the user, and then we just go to update the current states so we can continue again. Okay? Of course, if the current state at this point, at the end of the iteration, reaches the final states, that means we're done. If not, we're going to keep going. Any question at this top level here? All we talk about is just this part here. Only this part. We haven't talked about the other two levels yet, but we will. Okay? What's lacking right now is how does this execute states look like? That's a question. Okay? What you really have to remember is when we actually try to call the execute states from the execute session, we are basically passing the current states as an input to that, right? And as you can see over here, that's something to keep in mind. So now we want to see exactly how the execute state can be defined. Let's see that. Okay, so now for execute states, so what should we do over here? According to the diagram, okay, we have to basically, for every state, we have to somehow display, we somehow have to read something from the user, correct, do some validation, and also we have to display some error message if appropriate. And also we're going to process the input from the user. So now, how would execute state look like? That's the question. Can you imagine what's going to happen? Based on the diagram we have over here. Based on the diagram over here, it seems like this execute state is going to be subdivided by different stages, right? Maybe each stage corresponds to a helper feature. That means it's going to call further. But I have a question for you. when you call those helper features, is there anything you want to pass to them? Or just call them without any inputs? Huh? The choice? Well, not the choice, the state, right? Which, okay, that's right. Okay, let me just illustrate to you. Again, remember that we declare the current states, that'll be lighter. We declare the current states in the execute session over here. That's what we declare over here. When we go to the second level over here, we pass the current states into execute states. And now execute states is going to be subdivided by 1, 2, 3, 4, 5 different stages. Each one of them can be handled differently by a different helper feature. But the problem is, if I want to display, I really have to know where the current state is. If I'm in state number 1, I might display differently from if I'm currently in state number 2, right? So that means we have to, again, pass the current state to every one of them. What we end up with is we are passing the current states along between every level. That's what's happening here. It might still work, but again, we're going to criticize whether that's a good design or not. We'll get there. Let me show you the code very quickly. Okay. So now let me just show you maybe on the iPad directly. That might be easier. Okay, that's exactly right. So we're going to see a lot of helper feature call or helper method call. Okay, let's see that very quickly. So now we are talking about this particular feature over here, execute states, which is going to be subdivided by display, read, correct, message, and process. We got display, we got read answer, read choice, correct, message, and also process exactly like that. Okay? For execute states. And notice one thing. As I highlighted over here, for every feature we're trying to call, we all have to pass the current states. As we said, for every one of them. You can see the pattern for this particular feature very easily, so I'm not going to bother you with that. What I want to highlight to you is the difference, the commonality over here. For every helper feature we're calling here, we have to pass the current states. Okay? So now, let's go a little bit further. For every feature at the level 1, the bottom level, okay? For example, I believe that what I'm going to show you will be display. Now, how is the display structure going to look like? Before I show you the code. How would you implement that, let's say? Let's say that's a starter code we gave to you so far. Now I want you to implement the display feature. And we know that the display is going to take only one single parameter, right? You can see the display over here is going to take only one single parameter, which is current states. Now, how is the structure of display going to look like? Anyone want to try? Current state is of type integer. What should I do? Case? Sure. Case what? Let me write it down. Sure. You might say case. I'm not sure exactly the syntax. I say case. Let's say current states of something like that. You might say either it's 1 or 2 or 3 or 4 or 5 or 6, right? For each one of them, you might do something differently depending on what the current state is. Agree? Well, you know what? In some way, I wonder if you can draw a connection from this particular structure. Oh, of course, you can implement case rather than using case. Yeah. True, true. Yeah, that's exactly what I'm getting into. Yeah. Mm-hmm. But it's not subjective, right? You gotta explain. You gotta justify why you don't like it. Okay. Let me ask you this: if we implement it using if statements, we say if current state equals 1, do something. Else if current state equals 2, do something, right? We talk. Yeah, that'll be very well. It's gonna violate some principle, which we'll get into. We talked about this kind of a similar structure before, if you remember which lecture it is. Not design pattern. Generics. If you try to retrieve something from any collection, like a collection of any, when you retrieve something from there, you want to say if the element instance of was attached to a particular type, do something. else if is attached to something else, do something else, right? It's exactly the problem we're running into. You can see this kind of problem here is very abstract. It doesn't necessarily have to be in a particular context. It can just appear in general in this sign. So that's something I want you to draw the connection to. So now we know that it's very bad. Okay, let's see how bad it is. Okay, let's go to the display. Okay, execute state we just went over. Okay, again, the number one important thing for you to notice is that for every feature we're trying to call at the bottom level, you always have to pass the current states. Okay. So now, basically, okay, I'll just give you a summary table what each feature should do. Okay, just again, you can see every one of them should take s, which is integer. Okay, very good. Now, how similar are the code structures for each of the feature? Are they going to be similar? Basically, I'm asking if I want you to imagine the implementation of display versus the display for re-answer. Are they going to be similar? If they're similar, how similar they are? And how are they different at the same time? Let's sketch the idea before I show you how it would look like. Okay, so now let me just start you with something here. Oh, sorry, over here. Let's say we got display. Okay, and then we know CS for current states. Okay, and then CS is not good. How about S, which would be integer? So that's the current states. Versus, let's choose one. Let's say display versus, let's say re-answer. That'll be okay. Okay, also current state, which is also integer. So now we want to know how are they similar and how are they the same. Oh, sorry, how are they similar and how are they different? Okay, anybody want to try? Let's talk about similarity. Well, this exactly follow your thoughts, right? How are they going to be similar? Since the parameter we're taking is just an integer, right? Representing the current states. We somehow have to be discriminate on what the current state is. Agree? So that means for display, I might say if s equals 1, then display something here. Else if s equals 2, then display something else. And you got else if s equals 3, etc. Depending on how many states you have, you're going to have an exhaustive list, right? What about re-answer? Are they going to be similar? How are they similar, right? Are we going to have the same if statement checked, right? Also, basically, all the branching condition will be the same. I'm going to say if the current state is equal to 1, and then I'll just highlight the difference in just a moment. At the top level, if the current state is equal to 2, you're going to read the answer in a different way. And also, else if the state is equal to 3, then depending on how many you have. The only difference is what I have to say inside over here. The pink part simply displays something differently according to where the current state is. And the orange part here simply says you're going to read different answers depending on what the current state is, what the current state will require. So the blue part is how they are similar. The pink versus orange is how they are different. That's a precise answer. Yes?
Can you do it with arrays?
With array? What do you mean with array?
Instead of checking which state it is, just receive it from the array.
So where do you declare the array though?
Outside.
Outside? Maybe show it to me. I can maybe discuss that in the class. Yeah, maybe show it to me. Yeah. We do use array, by the way, in the state pattern. Maybe it's similar to what you're thinking. Maybe. We will see. Okay, so this is what we have over here. Okay, so I'm only showing you two of the features, display versus re-answer. But now, if you look at, for every feature over here, every one of them is going to have exactly the same exhaustive check on the branching conditions, right? Even though the body of each branching condition is different. Okay? Again, lots of repetition. And what principle does it violate? Single choice principle. Thank you. So now let's see this. That's exactly what I said. Okay, the same. Okay, it smells. Okay. Okay, so now via the single choice principle. Okay, let's see why. Let me ask you this. Let's say if I decide for my particular application, I want to delete a particular state. How is it going to affect my code? Huh? Should I delete some code, right? Okay, for example, let's say I want to delete state number 2, for example, right? How is that going to be affected to reflected in my code over here? If I want to delete, for example, if I want to delete state number 2, I need to basically delete this particular fragment over here. Also, I need to delete this particular fragment over here. Depending on how many states I have, if I got 100 states, I need to delete 100 times. Agree? Similarly, let's say I want to add a new state. Similar, right? If I want, let's say currently I've only got 6 states. I want to add a new state called 7. What should I do? Well, yeah, exactly. Okay, let me just for completeness. So what I should do is, so I might say, okay, how about green color here? If I say I want to add a state 7. Okay, I'm going to say else if s equals 7, and then do something over here. And also going to add it here as well. Depending on how many features I have, I need to modify that many times. 7, and then do something over here, right? Got to do multiple times. So single choice principle is not obeyed. Either you want to delete the states or add the states. But you should really expect for your kind of system, adding or deleting states should be a very common operation to perform. So you don't want to violate single choice principle always. So that's why this is not a good design. And the very reason for violating the single choice principle is because you are letting every feature over here to take the current state as information, as a parameter. That's a mistake. It's a huge mistake. If you're programming in C where you have no OO, that's acceptable. However, actually even in C, you can actually use record to actually solve this problem. But anyway, that's another story. But since we are in IFO or later on in programming Java or C#, if they do support object orientation, this will not be acceptable because you do have the construct to help you to get rid of this problem over here.
So what if you like this idea? What if you have this before going to the display, the execution state, right? The one that before the display. I forgot the diagram.
You mean this diagram here?
Yeah. So in execute state, what if you have a list that has like an array list that has
So where do I declare the array list?
in execute state?
Execute states? Sure. You mean over here, if I simply say array,
Yeah, if you have an array list, that array list consists, so we have, for example, like there's a five commands from level 1.
okay, wait. So here, so how do you want to call this? Should it be called states or what?
What do you want to call it before level 1?
Before level 1? I'm not, you know what? Yeah, go ahead.
What if you have an outside class for state which have features of execute state?
It would be better if both of you, maybe you got different idea, you may want to send me exactly how your design looks like. That'd be easier. So we can discuss that. I'm happy to discuss, but it's better to have complete information before I can discuss it. How about you put it down? Okay, you can give it to me on paper, and then we can discuss that. Okay, but at least we can see what the design pattern looks like. Maybe similar to your idea, right? Okay, maybe for you as well. Okay, good. All right. So now, what we agree, at least for this particular design, the very reason for violating single choice principle is because we are taking the state information for every call to the feature at the bottom level. Okay, that's why. Now, what's kind of the intuition for us to improve it? Okay, that's exactly what's going on over here. You're basically passing the current states from level 3 to level 2, and then from level 2 to level 1. Now at the level 1, you have no way around but exhaustively check what the current state is, right? So that's what we have. So now let's see exactly how we can improve the matter. Okay? Too much data transmission. The current state is being passed around too much. Okay, so now what we want to really know, so there is a law called law of inversion over there. Okay, you can also refer to the textbook for the OSC2. Let me read it to you. They said if your routine exchanges too much data, too many data, in this case the current states, the state information, then put your routines in your data. Basically what this is suggesting is if display, re-answer, validate, etc. If all these features must take the data for the current states, what we can do is put all those features into a single class. Okay? And that single class can be passed around. Well, not really passed around. I'll show you exactly what I mean. Okay? So now what I want to show you is a fundamental change over here. So now I want you to consider, basically there's a very important diagram change over here to understand. Okay? So let me illustrate to you. We'll get it one step at a time. Let's say for the bottom diagram over here, so this is the hierarchical design we talk about. We started with execute session, and then we go to execute states, and then go to each of the bottom level features. We pass around the states. For example, if the current state is stored in this variable over here, we got to say execute session and then current states, right? For example, this is just one of them. And then for execute session, you got to say, for example, read, and then current states. And the current state is being passed around. Now, we want to see how we can move from this hierarchical solution to a OO solution. Okay? The idea really is, since we are trying to pass around the states, okay, let me just show you. Since we are trying to pass around the state information for all these features over here, okay, these. So what we will do is, we're going to make those features into a single class called states. A single class. Oh, maybe that's what you meant? Oh, good. So you kind of thought ahead. Okay, that's what you meant. We'll get there. Okay. We'll see. We'll see. Yeah. Basically, conceptually, basically, we've got different kinds of states. The state can be, well, depends on which state. It can be number 1, number 2, right? Depending on what state is. Okay. And then when we execute the states, basically what we have is this. Now, let me just see let me give you a new page and tell you the differences, and then we'll go over the architecture. Non-OO solution versus OO solution. Okay? The non-OO solution goes like this. Maybe I'll say the current states, for example, is somehow assigned to 2, for example, right? And then I'm going to say execute states and then 2. And then let's say I reassign the current states into another states. It's assigned to 4, for example, right? And then I'm going to say execute states again. Let's say 4, just as an illustration. Okay, you can see that for this one here and this one here. Oh, sorry. You know what? What I really meant to say over here is not just a number. I think I meant to say over here, current states. Sorry, that's what I meant to say. Okay, that's a non-OO usage for the pattern. Okay, over here and over here. Okay, depending on what the current state value is, we're going to execute the state accordingly. Okay, what about the OO solution? Basically, OO solution, we're going to, let me just tell you exactly how it's going to do. You see if you can imagine that. In the OO solution, we're going to basically change input into context objects. So what does that mean exactly? Like this. So what I need to do for the OO solution, I will first of all declare. I can say current state. I'll use the same variable name just to show you exactly how it is different. Current state is declared to be static type states. Presumably, the states support the execute, okay, the feature. So now I'm going to say, first of all, I can say creates. And let me just look up the diagram very quickly. 2 and 4, right? 2 and 4. Just give me one moment. So flight inquiry versus reservation. Okay. So later, if you study those, you'll remember. Okay, so now this flight inquiry current states dot make, for example. Okay, and over here, I can also create another one. Okay, I'll tell you what to write over here. Reservation. And then over here, I can say current states dot make. Okay, you can see over here the static type. If you let's try to review a little bit our lecture. State is a static type, right? And now, is this a valid creation over here? It should be, in the sense that we're going to see flight inquiry is a class name, which should be a descendant class of states. So that's why it can be a dynamic type. Similarly, reservation, which corresponds to state number 4, is also another class, descendant class. So now, what should I write over here? So now, rather than writing this and writing this, I'm going to write something like this. Current states dot execute. No input required. In some way, as I said, we change from input parameter into context object. That's a fundamental change. Okay? And then over here we say current states dot execute. So now let me ask you very quickly. I'm going to revisit the point later. Okay? If I say current state dot execute and current state dot execute, remember the thing we criticized a lot previously. In the non-OO solution over here, we criticize this particular structure in the non-OO solution because the current state is one of the is the input. We're going to distinguish between that using exhaustive if statements, right? But now, if we try to use the OO solution, do we still have to write that particular exhaustive checks? Do I have to say if the current object's instance of maybe flight inquiry, I do something. Else if the current object is an instance of reservation, I do something else. Do I have to? Why not? Dynamic binding. That's exactly what dynamic binding will do for you. So now we delegate all the exhaustive check to dynamic binding. As long as you can create an appropriate class hierarchy for inheritance. Okay, guys, I think that this slide is really important. So later on, if you want to review the state pattern, this is the page to look at first. Because we are really trying to move from non-OO into OO solution. Okay, and we're basically changing from input that's being passed around between levels into just context objects. And this will work simply because we have a nicely, appropriately designed hierarchy for the inheritance. Okay, let's see that. Okay, we've got about 10 minutes or so. Okay, let's do as much as possible. So now what I would like to do is to show you, again, before I show you the code, I want to show you the design diagram. So this is the design diagram for the state pattern. Okay, let's have a look. Okay, this is the design diagram. Okay, let's have a look to see how we can understand that. Okay. Now, we start with the clients. Any client who is going to use a state pattern, for the client itself is effective, right? They're going to have a client-supply relationship, okay, over here. So that means we're going to have a green arrow over here. This is a client supplier to go to the state class. And notice that the state class is deferred, which means the state itself may contain some features that are implemented. Okay? And this is a client supplier. Okay, notice one thing. This is enumeration of all the features we're going to support for the states. Are all the features deferred? According to what I drew over here. No, right? There's only this one single feature that's not deferred. Execute. That's simply effective. Now, before I'm going to do as much as possible today, I think it will be very useful for you to understand at the runtime what's going to happen over here. Remember back in your lab number 3, we talked about something called template pattern, right? In the class. That it might be worth reviewing that part quickly. Okay, the hierarchy there. Okay, I'll try to draw some connection when I come on Monday to draw you some diagram quickly. But when I talk about template pattern previously, I said we're going to cover that again. This is now, okay, to cover the template pattern. Basically, the reason that the execute feature over here is effective is because it would be nice to share the code for the execute for every one of the subclasses in the state class. Okay, because if you look at the execute from the previous slides, you can see for the execute, which we're going to define more or less in the same way, but just in an old way. The execute is simply just a pattern for how you can do assign an initial state, do some transition, do some execute, and then do if there's a final check, right? This pattern is nice. We can reuse it. But we don't want to duplicate this pattern for every state class. Okay? This pattern over here, we want to just repeat just once in the execute feature over here. So it's going to be inherited to this, to all the 6 classes over here verbatim. The only difference is the helper features this execute depends on, they will be deferred. For example, read, display, correct, process, and message, they will be deferred. So when at the runtime, when you call the execute, it's going to execute that particular version of execute. But now, for all the sub-features, it's going to have the dynamic binding. That's something we'll see, okay? As a very quick preview. Okay, let me show you one more thing here, and then we'll look at a little bit of code. So exactly like what I said, so you can have s of type states over here. And then you can always say s.execute over here, and s.execute. And notice one thing, just from the diagram, the architecture diagram. When I say s.execute over here, maybe try this. Okay, s.execute and s.execute. Whenever I say s.execute, it's always going to execute this particular version that's defined at the top level. Okay, that's why it's called a template. However, that execute feature over there is going to, let me give you some example quickly. Okay, this particular execute feature in the state class, okay, it's going to somehow depend on, let's say, the read, also display. You can think about it's going to do something like this. The execute, we're going to show the code in just a moment. I want to show you quickly. The execute is going to say, for example, the current states dot, let's say display. Let's just do one of them. Okay, so this one will be good enough. Let's say this. If I try to execute this particular line over here, when I say s.execute, first of all, I'm going to execute this particular version of the execute, right? Which is here. There's only one version that's defined in the state class. But now, if I try to execute the body of the execute line by line, what's going to happen? The first line is going to say current.display. What's current at the moment? Current is s, right? Now, what would be the version to call for s.display? State inquiry, right? Simply because you can see that, for example, display over here at the state level is simply deferred. So it will be actually be implemented in this particular class because that's a dynamic type. Okay, so now over here it's just going to call, for this particular version, it's going to call the sit inquiry version of display. And similarly, before I answer your question, very similarly, let's say now I do another line over here to say create, change the dynamic type for confirmation, okay, into confirmation. Now, if I do the same line as the execute, okay, two things. Which version of execute am I trying to execute here? Oh no, execute. The top level one, right? Still this version here. There's only one version of execute. We're still going to execute this particular version here, but now when we try to execute the same first line over here, now current is still S, but now its dynamic type has changed to confirmation. So now which version of display are we going to call? Confirmation, right? So now this is going to call the confirmation version of display. Okay, I'm just sketching around the architecture diagram to actually give you some intuition. Okay, so what you want to know is to really understand the state pattern well, you want to know what is being defined at the state level. Some features have been made deferred just because we just cannot decide how to implement that. Some feature has been implemented just because we want to share its code in the subclasses. Okay, so there are two categories over here, but we'll see. Okay, questions? Yes, go ahead.
First of all, if you execute it every time you make it, why not just put the execute in the main feature?
It's different because now it's again separation of concern. Because now the execute here is only specific to the concept for states. So if you move it outside the state, it's now again a cohesion problem. That's not something you want to run into. You want to make sure all the features related to the state should be put inside the states. If you move it outside the state, put it in the main program, for example, right? It might still work.
No, in the make.
In the make? What do you mean?
When you create it, it's automatic.
You mean, oh, okay, maybe I misunderstood your question. You're saying that you need to actually put the execute inside the make? No, it wouldn't work. Simply because, you see, you don't necessarily want to call execute right away. Let me see this. Actually, later on you will see, we don't necessarily want to call the execute right away when you create a state. It's a bit too early to call that. Second question, yeah.
How do you distinguish which S are you talking about?
Which dynamic type, right? Because you can see it's the same variable over here. You can see we only declare one single state variable, but now when we talk about this particular one, its dynamic type is actually seek inquiry, right? When we talk about this particular, the same variable, but now its dynamic type has changed to confirmation. So even though you're calling the same feature, but it's going to have different effects because of dynamic binding.
Right, but let's say we want to switch back.
You want to switch back and forth for the states? That's something we'll get into. Right? We're going to get into the array you talk about. Okay?
That's what I was
Yeah, we'll get there. Okay, guys, any questions for this? Okay, I think maybe I'll stop here, okay, for now. And then we're going to finish this next time. And then